Okay, so we've got to investigate a couple of different scenarios. We want to know which of four scenarios is going to make to double the value of x. And remember, x is equal to this fraction a squared over b. So in order to answer this, what I did was assigned a value to a of 3 and a value to b of 4. So the initial value of a is 3 and the initial value of b is 4. I'm just making up those numbers. You can pick any two, but we're going to start with 3 and 4. So when a is 3 and b is 4, we get 3 squared is 9, 9 over 4 is 2.25. So a baseline x value of 2.25. Now we're going to go through, we're going to double the a value and see what happens. We're going to half the a value, see what happens. We're going to double the b value and see what happens. And we're going to take half of the b value and see what happens. We want the one that's going to double the value of the whole fraction. So when I double the a value, now a is 6, so now it's 6 squared over 4. I get x to be 9. Did that double the original x value? No. So choice 1 is not accurate. Choice 2, I took half of the original a value. So now it's 1 point, which is 1.5. I did 1.5 squared divided by 4. 1.5 squared is 2.25 divided by 4 is 0.5625. Is that twice as big as the original 2.25? No. Thirdly, I doubled the b value. b is 8, so now it's the original a value 4 squared over 8. That's 16 over 8 is 2. Again, not double the original. And then the last one is I took half of the b value, which is 2. So now I have 3 squared. The original a value is 3 squared divided by 2. So we get 9 divided by 2, which is 4.5. And is that double the original? Yes. So taking half of the b value in this case doubles the entire fraction. You can also look at it this way. The fraction is a squared over b, right? If you take half of the b value, now then you're going to get a squared over 1/2 b. And remember, when you divide by a fraction, divide by 1/2, that's the same as multiplying by 2. So if you have like a squared divided by 1/2, that's the same thing as, you flip it and multiply. So it's 2 times a squared. A little bit more symbolic, but this is probably the more understandable method. Choice 4. Okay, number 20. Number 20, to be honest, I don't think it's the greatest question, but we're going to do it anyway. It's fairly reasonable. Basically, we got some test score data here, and we want to know, like, of these 4 choices, which one seems like the most reasonable line of best fit. None of these are the linear regression line or any of that, but which one's like the best of the 4? So all I did was kind of informally just kind of sketch. This is method 1, sketched in a line. And then I thought, what's the equation of the line that I sketched in, approximately? So the way I did it was I took it back to 0 here, and it looked to me like my line went through the point 0.65. So I said 0.65. And then it also looked, when it was at 1, it looked like it was around 85, so 185. Now I picked 0 and 1 because that's the easiest to calculate the slope from. So I have a y-intercept of 65, and then I have a slope of rise over run. So it goes up 20 and a run of 1. You can see it on the graph too. It goes from 65 to 85 up 20 as it runs over 1. So the slope is 20. So I got the equation to be y is equal to 20x plus 65. The closest one to that is choice 2, and that's what they have as the right answer. The other way that I did it was I went in and estimated the data. I went to stat, and I went to edit. And I just looked at the data points here, and I said this one's approximately 0.3 comma 65. So I put in 0.365. I did the next one I said is approximately 0.6 comma 78. 0.678. I put in the 5 points, and then I just went to stat, calc, linear regression, and when I did it, I got the y-intercept to be 60.1 and the slope to be 23.6, which is pretty close to mine. But again, this one's not really exactly it, but it's the closest. So choice 2 seems best, but again, it's not fantastic.